Greetings, hi all. This is Srinath Vasam, Faculty for Mobile Communications in Regional Telecom Training Center, Hyderabad. RTTC Hyderabad is offering a number of courses in mobile communications and at the same time a number of projects in mobile communications, especially coming to the fourth generation LTE segment in the segment of radio and in the segment of core also. And we are offering a number of projects in the direct tunneling, PCRF functionalities and LTE domains. And at the same time, coming to the radio, we are offering a number of courses in the radio planning and at the same time optimization parameters and all. And we are offering some projects which is in-depth study and the key performance indicators which are involved in the radio segment at the same time. And also, right, we are offering a number of projects which we are dealing with a number of protocols which involved in the core segment of the architectures and all. So coming from 3G to LTE, now we are going to discuss about 4G architecture of LTE in brief. So LTE is long-term evolution which is a part of 3GPP releases, and when it comes to the 3GPP, the 3GPP evolution started, the partnership project basically started from for 3G technologies, and when coming to the 3G it has started from the release 99 and there went from release 99 to release 4, release 5, release 6 and 7, and till 7 there was a high-speed packet access beyond, we reached in the UMTS network. And then for the release 8, we call it an LTE, long-term evolution. And in fact, coming to the release 9, so we have given something like LTE interoperable with the UMTS network number. And coming to the release 10, we have went for the LTE advanced. And 11, 12 is a proportion, and at the same time we have introduced the IoTs. And the release 15, so where we have introduced the new radio systems and at the same time heterogeneous networking concept and all. So that we treat as a 5th generation, and whereas coming to release 8 onwards, the LTE onwards, we treat it's a 4G, right? And coming to our 4G architecture and all, so basically the 4G architecture can be divided into two parts. So there is a radio part and another is a core part. Yeah. Here in the LTE radio, we'll be discussing about the OFDMA, which is orthogonal frequency division multiple access, and we'll be discussing about multi-carrier assignments, sub-carriers, and we'll be discussing about the carrier aggregation, right? And we'll be discussing about MIMO concepts also, multiple input, multiple output. And at the same time, we'll be discussing about some key performance indicators which involved in the radio part, which is used for the optimization and at the same time for the radio planning. And at the same time, we'll be discussing some parameters regarding the interlayer mobility management and all. And when it comes to the core, right? So what we call is evolved packet core, which is we are having MME, SGW and PGW. That MME is the mobility management entity and SGW is a serving gateway and PGW is a PDN gateway, which is a gateway to the packet data network, which is nothing but the internet cloud. And at the same time, so we will be having an HSS, HLR subsystem unit, which is the integration of the EIR, Authentication Center and AUC when we correlate with our 2G technology and all. And at the same time, so when it comes to the EPC, so we have segregated this EPC into two domains, right? So one we call it control plane and another one we call it barrel. So basically the MME entity which falls under the control plane, or we call it a signaling plane. So whereas SGW and PGW, these elements fall under the barrel plane activity or not. So, and at the same time we'll be having some other features in LTE. So that is something with the policy charge ruling function. So which you provide an extensive services for the user. So when it related to the policies and chargings, etc. And so to understand the functionality of the control plane and the bearer plane, so we'll correlate with the predecessor GPRS domain. So where a tunnel creation happened from the SGSN to the GGSN. So the way SGSN is communicating to the control plane with other signaling databases, right? For the creation of the tunneling to the to the SGSN, so that a tunneling is created from the SGSN to the GGSN, and similarly, so here some radio access barrier has been created in the radio, and at the same time some barriers has been created in the data part also, right? And in the LTE, we'll be discussing in brief about evolved packet core and at the same time the radio access technologies and all. Let us discuss about the possibilities of the voice calls in the LTE. So there are two possibilities in the voice calls. One is using the same LTE network, using the packet switching. Another we are using falling back to the circuit switching domain and all. So basically, when it comes to the Vivo LTE, what we call the voice over LTE, where the voice can be used, voice call, the bearer and the control plane is used as the same existing LTE network, and here the IMS plays a vital role, and IMS is mandatory. So if we don't need a IMS, basically in this SRVCC is an interim solution, what we call single radio voice call continuity. So it is an interim solution provided. So before implementing of the IMS, right? So when the customer is moving from one network to the LTE network to the another legacy systems and all, basically it is a kind of handing over procedure from the LTE to the legacy systems and all. And another we are having is CSF procedure, which is nothing but the circuit switch fallback procedure. So which is nothing but when the voice call happening from the user, so basically the user is going to latch to the legacy system, and legacy system is taking care of, circuit switch domain is taking care of that voice call and all. So in fact, in the course we will be dealing with the CSFP processor in detail and SRVCC processors in detail, and at the same time Vivo LTE, IMS implementation and everything. And thank you, one and all.